Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly, right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank ExcelR for being a part of it.
Good evening, all. I hope my voice is audible. Okay, so students, kindly inform your friends to join the session. As I can see, the participants are very less. Please inform your friends to join the session. Okay, as you all know, from today we are starting with a new topic, that is ML, that is machine learning. So we have a new trainer. Shahid sir, is I'm audible to you?
Yes, ma'am.
So sir, you can take over the class, sir. You can start the
Okay.
session further.
Okay, ma'am. Thank you.
Yeah, thank you.
Yeah, so let me share the screen of the PPT. So Yes, ma'am, please confirm if PPT is visible.
Yeah, yes, sir, it is visible.
Okay. So, good evening, everyone. So, my name is Shahid. Today, from today, for the I think 8 days, I'm going to provide the session on machine learning. We will see in this course basics of the machine learning, and we will try to implement the projects using Python and different Python libraries. So let me start, and I will give you the agenda of day wise, like how what are the topics that we are going to cover day wise. Okay. Yeah. So basically today at the first day, we are going to cover introduction to machine learning, and in the machine learning, while we are going to introduce, so we'll try to cover ML basics, what are the machine learning, and two different types of the machine learning that we will try to cover. If time will permit, then we will take also the reinforcement learning. Okay. So we'll try to cover machine supervised learning, unsupervised learning, and reinforcement learning also. And we'll see how we can create our first ML model from scratch. In theory, not in practical. And we will try to set up tools like Python, Jupyter Notebook, and Pandas, NumPy, Matplotlib libraries. And also we'll see that how to load the data set using Pandas library, and to explore how our data set will look. So if we go day-wise agenda, the first day, that is today, we are going to introduce what is the machine learning and what different types of the machine learning in theory, and we'll look about the Python and Jupyter Notebook and different machine learning libraries that are required. And the second day, we'll try to explore supervised learning, and that will basically will focus on the regression. Different types of the regression we'll see: simple linear regression, multiple linear regression, and different type of other non-linear regression we'll try to see. And also daily we'll try to implement one program. If suppose that we are taking linear regression, simple linear regression, so we'll try to implement using dataset, Jupyter Notebook, and Python programming language. And we will see what machine learning library like scikit-learn will take for the model. And the day 3, we will take supervised learning, that we are going to cover classification, different types of the classification we will take. And on fourth day, we'll try to cover unsupervised learning. And in unsupervised learning, we'll try to cover clustering. We'll take 2 or 3 methods, algorithms to cover this unsupervised learning. And on the 5th and 6th day, we'll try to focus on the data set and model evaluation. Okay. So before building the model, we'll try to do data pre-processing and some feature engine. And then we will do the model. We'll see what different types of the model evaluation metrics are there. And then we will go to directly jump to the project, and we'll develop the model using scikit-learn and other libraries we'll see. And yeah, so finally on the day 8th, I think at the day 8 we will have only 1 hour, so we'll try to finalize the project. Okay, so let's understand what is machine learning. So today we'll cover these things that I already have discussed. So let's understand what is machine learning in layman term. So suppose that you want to introduce, we all are related to the machine learning. Some are students and some have the experience. Okay, so but if someone say that how you are going to explain what is machine learning, how to introduce machine learning to someone who is uh, not technical or not know do not know anything about machine learning. So we'll make an analogy that how a human uh, understand something and how what is the things that a human learns, how the human is going to learn from childhood to the things. So we'll see that how a human can learn from the, so whatever the learning process is for the human being, that is basically we learn from the experience. So whether we are experience is everything, like whether you are reading a book, that is also you are experiencing something, you are having some data, you are feeding yourself some data. So this session is also that this is also experience, that you are learning something from experience. So like way the human learns from the experience, same way we are going to understand that how a machine is going to learn from the experience. And when we talk about the machine, so we are going to say that machine, generally what machine is basically, let's understand as a software or as hardware and software both as a machine. Okay, that machine how can learn? If the machine is learning from the experience, means we are providing data. And data may be different types of the data, label, unlabeled, structured, unstructured, different types of the data are there. So basically, we are going to make an analogy between human understanding, human learning from the experience, and machine learning from the data. So data is say similar way that we are learning from experience. So experience is data for the machine. So suppose that a human have to understand that what is this object. Okay, so suppose that a human or someone who doesn't know the car. Okay, so how to understand that this is a car or what any other object. So basically what we do, we try to show some examples, some experience. Basically this is the experience when we are showing some examples to a human or a human being, that with the labels, that this type of the object is basically what, this type of the object is car, this type of the object is car, and this type of the object is basically bike. So human can understand, okay, he or she can understand, okay, four wheels are there, height and width, and on the basis of the features, we will introduce later on what are the features in machine learning and the data set when we're talking about data set. So human can understand by experience, by seeing the objects. And the similar way, see that if we go and see that it's if this object is asked a person who have never seen this type of the objects, never seen a car, a train, or bus, something like that, someone who is living in a jungle, or like say tribal persons who never went to the city and haven't seen that how car looks like. So so what, how can we understand, how can you make understood that person that this is a car? Because you see that if he is living in a jungle or somewhere where not in city basically, or not in where the cars and all these things are available. So he don't know that what is this, but he can recognize the things that he already have experienced. Okay, so whatever the data set or the data or the experience he or she has earlier, he can recognize the object, but the new thing he is not able to recognize. So what we observed, yeah. But human being has some intelligence. Basically, you see that we whether he has seen the object or not earlier. So he has some intelligence. So he can learn. He can observe and learn. So see, these things are there. We will try to. So we are feeding. Basically, we are giving him means experiencing him that this object is car, this object is bike, something like that. So he can learn from these things that okay, this type of the object is car and this type of the object is other object or bike or something like that, bus is there or whatever we are. Then now in his database or in his data that experience, these are the jungle animals are there, and now these are the cars and other things he can recognize on the basis of experience. So same way, just try to understand a machine. How a machine can understand object, how can recognize something, how can make the prediction or something like that. Okay. So basically, machine generally what we say, machine follow some instructions. It cannot work on its own. Like human, we can work on ourselves, but machine has to follow some instructions. So how it will go? Okay, what different types of the tasks that we already know. These are the things that are not the example of the machine learning. Okay, these are the examples or the traditional machines that machine can perform the task. So we'll try to understand the difference between the traditional machine programming and the machine learning. So if you see that what different types of the tasks machine can perform, so it can perform like different types of the mathematical things it can perform. Okay, different types of the tasks it can perform. Comparison, print, it can do a lot of things. Okay, different types of the things, but these are not the examples of the machine learning. These are just the example that we are covering, that what are the test if traditional type of the machine algorithm, you can say, on machine programming. But what if we want to let's say that we want to act machine like a human, means it can have some reasoning, or it can have some it can learn something from the experience. Okay, without, so generally we say that machine can learn from the experience, from the data, without explicit program. Okay, so for a particular task, the machine is not programmed for a particular task, but machine has some algorithm that can be trained on the data, on the experience, that in case of human, that can be trained on data, and it can perform task like human. So that, let's say human can guess that, okay, so price, what is the price in 2025? We have seen, we haven't given the something experience like these things, data, that what is the price, and we just seen that this object is a car. So can the machine predict what is the price in 2025 or in near future 2026 or in other like 2030. So one of the tasks that machine can predict, if machine can predict, then we are going to say that machine has learned from the experience, and machine has some decided, has some find some rules to output, to give the output. And the other example of the machine learning that a machine can work is natural language understanding. So machine, like we have seen all the things, we have experienced these things. So if you have written, I made him yesterday, so machine can understand that, okay, this is grammatically incorrect. So it can. So this type of the task will go into the machine natural language understanding or natural language processing. Machine can, and all these are the tasks that human can perform. See here, machine can predict, okay, the particular type of the model, the price is going to increase or decrease. Okay, machine and a human can do this type of grammar correction, and human can recognize the face. Okay, you can recognize the face of your friends, families, and if unknown person is there, and you have given the experience with the name and name of the unknown person, so you can in future you can recognize that this person is this picture, this face is for the particular person. So face recognition is also a type of the machine learning, like human can recognize, a machine can recognize the face. So we can conclude that like a human can, like a human, machine can uh, learn from the experience. Okay. So what that we have to learn about, let's go into the data set and experience and data set. So like we have done for the human being, for let's say that human is learning from the experience. Same way, if we are talking about machine, so we are saying that the experience is basically what? Data. And we have to give the data set or data to the machine, but machine itself can't understand the data. So we need other things. So generally what we say, the learning process, when we are learning or the human are learning and machine is learning. So the learning process is basically called a training. So when we are learning or the machine is learning, so that process is called a training process. Training, how machine is going to train on the data set. So we have to understand in detail that what other things or different things we need to train a machine to learn on the data set. So basically, data set that we need. So first thing is our data set that we need, training data set. So on what the data set that machine is trained, the machine is going to learn something from the data set. That data set is called training data set. So we'll see that other types of the other part of the data set are there, like testing data, test data set or the evaluation data set is there. So when a machine learns something, some rules, some from these data set, so we are going to evaluate that whether machine has learned sufficiently well or not. So we'll see in the later days, we will have it one day for this thing for the evaluation, machine learning model evaluation. So first understand that whatever the data is there, so we call training data set. Now, this thing is not enough. Machine software, that a machine or the hardware plus software machine, and the data set. This is like, suppose that we have our machine, that is laptop or the system, and we have data set also. So these two things are not sufficient to learn. That machine is not going to learn on the data set with the data set or training data set. What the particular thing that we have to learn, and that is the main part of the machine learning, that is basically algorithms. So algorithm is the main part when we talk about learning. So this algorithm, these algorithms are trained on the data set. Algorithms, we are going to see that what are the different algorithms. Suppose you are going for the regression problem. You have a machine learning problem, that is regression problem. You have a system, you have a machine, you have your data set. Now you have regression, let's say linear regression or the simple linear regression machine or the multiple linear regression. So for that thing you have algorithm. So regression algorithm, different types of the regression algorithms are there. So algorithms, basically these regression algorithms are the any machine learning algorithms are the piece of programs you have written in Python, or you can write in different programming languages. So these algorithms, basically the steps that how algorithm shows that how this machine is going to learn on the data set. Algorithm will define that what are the steps that the machine is going to learn. So basically we are going to say after learning. Okay, so after learning, machine learn something. So machine may have find some pattern, may have find some rules on this data set. So let's say that machine finds on the basis of this algorithm, machine finds that if an object has 4 wheels, so this can be categorized or classified as car. If 2 wheels, then it can classify as the bike, or different other tasks. Other task is like if you are going for the regression task, that what will be the price prediction. So if prediction is there, the algorithm learns something, some rules that it can predict on the basis of data set. So we will see that what different types of the features we need, and on the basis of those features, how machine is going to learn. So when machine learns something, so machine can predict, machine can classify, and if you go, machine can even make clusters, making clusters of these two objects look similar, and these two objects look similar. So it can make clusters of similar objects. So there are different types of the machine learning tasks that we can perform. Okay, we'll see when we are talking about supervised and unsupervised, and we can go with the reinforcement learning also. So we'll see. So we'll see how a supervised learning, what will be a supervised learning, what will be unsupervised learning, step by step, everything. We will see all the things. So let's move ahead, and we have seen that this is basically what algorithm. So you have machine, you have data set, and you have algorithm. Now what we need? So when machine learning, or when machine on the basis of this algorithm and on the data set can identify some rules. Okay, if some rule is there, how objects are related, what different types of the object, can also find some pattern. Okay, is there any pattern? If two wheels are there, then okay, this can be a car. If four wheels are there, then it can be a car. If two wheels are there, okay, so some patterns, it can find some pattern. Okay, any relation is there. So different types of the things it can. So what are different things? It can identify rules, some pattern, some relation. Okay, so you see different types of the machine learning task. In different types of the task, we will find different things. We find the relation, we find the pattern, we find the rules. Now, on the basis of these things, it has decided. Machine has learned some pattern. Machine has learned some rules and other things. So now machine is able to perform some task like a human can perform. Okay. Now, whatever all these things, algorithm is there, data set is there, and basically hardware and software, that machine is there. And the learned rules and learned pattern and learned things. This will be called your model. This is basically model. So when machine when algorithm is trained on the data set, now you will get your model. So in machine learning, we will take an algorithm. So we'll see how to select an algorithm, how to select a machine learning model, and how you are going to train that algorithm on the data set. What are the different steps? And after training, whatever you will get the model, and this model means that now learned machine on the data set, learned machine can predict, can classify, can cluster on the basis of the problem of the machine learning, what types of the problem you have given. So on the basis of the problem, on the basis of the features which type of the data set you have provided, machine can do different types of the task. Okay, it can make prediction, it can classify different types of the task. So on the basis of these things, we will understand what are the different types of the learning on the basis of the data set, on the basis of the supervised, what different types of human supervision is there. So we'll see all these things in detail. So the basic is that we have to know the model. What is basic model in machine learning? So basically we have algorithm, we have data set. Algorithm is trained on the data set. And obviously all these things, algorithm and data set is trained on some machine. So you are training your data set, your algorithm on data set. Where you are training? You are training on machine basically. Okay. So later on, machine and this algorithm, we will combine these things as algorithm, and you will see the algorithm is trained on the data set, and now you will get these rules and these rules and other things, and on the base, this thing will give you a model. So let's move ahead and try to cover whatever we have decided. So you see here, whatever the problem is there, you have a problem, you have a data set, now you have algorithm, and now after training the algorithm, the machine, you have defined some patterns, some rules, some other things. And now the machine is going to perform some task like a human can perform. Okay, so you can see here what basically machine. So for starting machine learning journey, you have ML problem. ML problem is that any task you are going to perform, any model you are going to perform. So beforehand, you have the problem. For that particular problem, you need data set, appropriate data set you have to find. So suppose that you are working in a company where uh, customers are there. Customers, let's say customer behavior, you are going to analyze that what are the customers are expending more, what are the customers, who the customers are expending less, or what different types of the objects they are purchasing, different types of the items. So different things you can perform. So if you are working on the customer segmentation or customer, you are analyzing the customer behavior, and you are making the customers into two groups, group one and group. Okay. So so appropriate type of the data set related to the customers and their income, their not you can find the income, but you can find the expenditure, how much they are expending weekly or monthly, different type of the things, male or female, age you can find. So the data set, you have to find the appropriate data set. You have the already you have problem that you have to, what is your problem? Problem is to analyze the behavior of the customer, or you are making groups of the customers, one high spending and the low spending or something like that. So different types of the problem. You have problem. Now you have a data set. You have to create or you have to find different types of the way. There are different ways to uh, collect data set or create data set. Okay, we'll discuss. Now you have data set. This you have data set. You have problem. That is what we're going to do. Now what you have to do? You have to have the algorithm related to you are going to perform, let's say classification or the segmentation. So what type of the this segmentation is. So in machine learning, we can find, you can work on different types of the tasks. Okay, so algorithm. So respective algorithm, you have to choose related algorithm that is uh, that is going to relate with your problem. Okay, suppose your problem is related to classification. You are classifying object as car or the bike or the bus, but you are taking algorithm, you are applying algorithm for the let's say regression type. So that will not. Okay. So you have to find appropriate algorithm, and that algorithm will be trained on the data set, and rules, patterns, or the relation uh, will be learned. Okay, so after learning some rules will be learned, some pattern will be learned, or some relations will be learned. Okay, so these are the things what are the learned, and with combination of all these things, you will get a model. Now this model will be able to predict or classify. It can create some rules, association rules. Okay, so you can say that now machine is able to perform some decision. So different types of the paradigms are, we are going to say the different types of the machine learning. Types you can say, for the types, how machine is learning means uh, we say that, okay, we are giving the data set, okay, but what is the way, what are the ways that machine can learn? So there are different ways, there are many different ways that machine can learn. So we have to cover, we generally we have to understand about supervised, unsupervised, and reinforcement learning. Okay, so basically we focus on the supervised and unsupervised, and in the later on we are going to cover all other related models, related algorithm. We will try to implement these things. So we'll see the supervised learning and unsupervised learning, and reinforcement learning. So let's say that what is supervised learning? Supervised means like a human, like how a human is learning. So a human can learn on its own, like uh, he can read a book, he can read something. Okay. Either a human is supervised, a student is supervised by teacher. So is there any supervision? So human can learn under the supervision of any other person or senior or the teacher or someone in your family. The childs are learning from the parents or the elder persons. Okay. But in machine learning, when we are going to say supervised learning, so we are saying that we are providing data, and on the basis of we are saying that what is this data. So like this, we have provided the object, and now we are saying that this object is basically a car. Okay, so we are giving the labels. Generally we say that this is label. We are giving the name of the object. What is this? This is car. We are giving the name or the labels of the object. So this, any data set, any data set has the data, the objects that basically are called samples, the values. So we'll look into detail what are these things. And the name of the objects are the labels, you can say, or the output, you can say. Okay, so those things are the labels. So if labels are given, so we are going to say that we can perform a supervised. We can train algorithm in supervised manner. If the labels are given or the outputs are given or the name of the objects are given, as a layman term, we are trying to understand if any non-technical person is learning. Okay, like a machine has nothing earlier before training. Okay, so we can say, so these things we are giving. So what different types of the task we can perform? So we have labels and the actual data. So that is sample. So these two things are called the data set. And generally, when we talk about these things, so we say that when this sample is basically we are representing this with capital X, and the output are the labels with Y, small y. Generally, this is the convention, not hard and fast rule, but generally we are trying to do like this. Okay, and this will be your sample. Sample may have different features. Okay, so you can say that feature 1, feature 2, feature 3, and feature 4. We will learn in detail these things, but here we are not going to discuss a lot. Okay, so features will be there. So this sample may have a feature like how many wheels are there, number of wheels. This feature, what is the height of the object, what is the length of the object, maybe another feature, what is the color of the object, that is another feature. So these are the feature, different types of the feature you may have. This will be sample 1, and respective the labels. What is the label? Sample 2 for this object, what is the what will be the weight or something like that, height or weight, color, something, these things are there. So we'll have samples, and these will be these type of the data set you will have. We will see in detail when we will work on the actual data. So just to understand that we need labels and the samples to get our training data set for supervised learning. So if supervised learning we are talking about, so it is must that in supervised learning we have label or the you generally say target, output. Okay, so you learn the different terminologies, target, output, and the labels, and these things. So in training data set, you have labels. So that is the main distinction between unsupervised and supervised. In unsupervised, we will see that these labels are not given. Means what is the data? Data, the name of the data or the output for this data or the labels for the data are not given. Okay, in the unsupervised. So, okay. So what is how what will be learning? If we go with the mathematics, little mathematics, if you can go with mathematics. So in supervised learning, generally in supervised learning, we are saying we have given these input, we have input features. So input feature, like we have said that maybe one feature is that for this number of wheels, other feature may be what is the height and width or the volume, you can say, volume of the object. Okay, other feature, different types of the features. So now on the basis of the feature and the output, on the basis of the feature, can it make some rule? The machine learning, can machine make a rule or the mapping or the function? Can it find a function between this label and the input? So basically it will be your output and it will be your input features, generally we say, but it is not here, not feature given, only the object are given. Okay, but we each object or each sample will have features. Okay, different features, like having how many here you can say how many wheels, that will be one feature. 2 feet 2 wheels, this is the feature of the bike. 4 wheels, this is a feature of car. What is the volume? Okay, how if the volume is bigger, so high in comparison to this object, so we are going to say that okay, this can be a car. So different types of feature you will have. Input feature, generally we say input feature, and if you go, that input feature will be expressed with capital X and your output will be expressed in small y. So this will be your what? This is the function, or this is learned rule. This is the rules that machine has learned something. F this x is basically and y. So this will be your output, this will be your input, and this is the rule that machine has learned. So you provide this is your basically already you have data set. On this data set, machine has find this rule, and now you are providing this object that is new one. So now the machine is able to predict or to classify this object using this rule. Using this rule or the function. If you go in mathematics, this will be function or the rule in general, that how the objects are categorized, which type of objects is car and which type of the object is bike. So now the machine is able to classify or able to recognize this object that is a car. Okay, so what will be the features, on what features machine has find these rules, we will understand different using when we will use a proper programming in Python and we will do with proper data set, then we will see. But to understand that behind the things that how machine is learning. Okay, so you have data set and you have algorithm, and let's say this f is your rule or your the function that machine has learned between the input, that is sample, and the output, that is labels. So in sample, between the sample and labels, how the machine has find the roles. Okay, so this is the training. So now this type C, this car is not in our data set, but still, if this rule or this machine has learned this rule, is able to classify that this object is a car. Okay, so this type of the things, that um, when the new object and new data is given, so machine is able to perform the task like a human. Okay, it can classify the new object. It can classify. It can perform different type of the task. So one of the important things that you can see here, if your output is discrete or categorical. Okay, so if you have car or bike, okay, this type of the things, this means your output is categorical. Discrete means like you have 0, 1, 2, 3, these type of the things. If output is like this, so this will also come into the classification if it can predict. So generally, like we are predicting cat and dog, different types of predictions. We have seen if you have gone through the CIFAR 10 or CIFAR 100 data sets. Okay, CIFAR 10 and CIFAR 100 data sets. So there are, in CIFAR 10 data set, there are 10 classes, like the car and bike. Here only 2 classes we have. In CIFAR 10, it has 10 classes. Means your object is classified under 10 category. Here in CIFAR 100 data set, you have 100 classes. So this type of the classification. So if you have discrete output, this is not the discrete, but this is the categorical. If you have discrete output, like if you have 10 classes, you can make 0, 1, 2, 3, up to 10 or 9. You can make it 9 classes like this. Either you put the labels, the respective label, that what is the name of the class and something like that. So these things. So let's move ahead and go quickly. So one of the things that you can see here, when you are going to predict or to classify this object, this is basically a bus. So still, it will classify either car or the bike, because we have trained the machine on only these 2 classes, okay, on these 2 types of the data. So it will classify either either car or the bike, and on the basis of the features, input features, it will try to classify. Okay, so if you have, if you trained your data set on only 2 classes, and you are inputting a different type of the object, a different type of the data, so it will try to classify on what classes this machine has trained. Okay, so this still it will predict car, because it looks more similar to the bus, or it has different types of things you can see. So now move to the other part. So if you see that this is basically data, and you have data and the labels, and the classifier will, this is the new, or the that is not in our data set. Okay, so this is new, it will classify the elephant. Okay, so on the basis of data set, the classifier is basically your model. Okay, so all the things that we have learned, that model. Okay, model, this model is basically F here. Your model is a classifier if the task is for the classification. So you are going to classify this object, that is new object, that is not trained basically. So you have training, this is these 4, 5 elephants are there, and these tigers. So on the basis of these, okay, this is the new picture, or the new the animal, and it can classify the it is elephant on the basis of the features it has, what different types of feature it has. Okay. So regression, other thing in machine learning, if you are in the supervised, if you go, okay, in supervised, if you go, supervised learning. So uh, one is that we have seen classification, so that we can create classifier, and in detail we will see that what is classification, and we will see different algorithm. We will train model using Python and machine learning library Python. We will see in detail. Okay, so one task that you can perform is classification. That is a supervised learning, and another task that you can perform is regression. Okay. So these two types of the task that you can perform under supervised learning. So in supervised learning, you have your data, input features, and also you have labels at the target outputs. So we have to see the other, that is regression. So the difference between these two, you will have data set, you will have the output and the input plus output, input features and output target are the labels. So if you say that your output values, your possible output values are the continuous. In classification, we have seen that output is basically either discrete or the categorical. Categorical like cat, dog, and this categorical are that 1, 2, 3, 0, 1, 2, 3, 4, 5. These are the discrete values. So that you can do this, you can perform the classification. And if continuous, like it you have seen, it has point values. Continuous means the real values. If you go in mathematics, you have, so if real numbers are, you are getting real number as output after the model, after performing the prediction or something, so that will be called your regression. So just we have to see. In this also, you will have your input feature and your output, and this output target, you can say target variable or output. These values will be real numbers. These values are real numbers. Or you in mathematics, we are saying that these are the continuous real values, continuous values. So we can perform a regression. Like the one example of the regression is predicting house price. Okay. Predicting house price. So in house price also you will have different, like x1, x2, x3, different features you will have. What are the, let's say that one feature may be the area, carpet area, you can say. What is the carpet area in square feet? So area you can say. Another you can say that how many bedrooms are there. Okay, how many bathrooms are there. Okay, different types of the feature you can have. Okay, so these values are these values on the basis of the feature values and the target values. In these, it will try to find out a relation between the x and y. Okay, so it will find some relation that, okay, this is the relation, and when you are giving the new type of the data, so these are the samples of the data. That is a bigger house, smaller house, it has these things. But you given the new type of the house, okay, so it will be able to predict the price of the new house. Okay, so how it can predict on the basis of the how it learned this rule, okay, and in between the output and the input features. So you will see in detail that when we will talk about, we have 1 day for the regression, and for whole day we'll try to understand regression in detail, and we will implement on the real data set. So you can understand on the basis of, so when we talk about the problem, machine learning problem, so classification is a machine learning problem. Classification and regression, two different types of the problem that we can perform as in a supervised learning. Okay, so whether you are going to perform a classification or you are going to perform a regression problem, that will depend on the label. Okay, if label is that we have seen continuous, so it will be a regression problem that you can perform regression problem. If discrete or the categorical label is there, so we can perform classification. Okay, so I hope that we have covered, we have just try to understand about the supervised learning. So let's move to the unsupervised learning, and quickly we try to complete, and we'll see some other tools and other things that we have to install, and other things that we need, libraries and machine learning libraries and data manipulation libraries. All these things we have to see. So we should go quickly. So unsupervised learning, we can see that these labels are not given. Only the data set, the samples are given, examples are given, and the input feature, you can say input features are given. Okay, but their output, their names, their labels, their target are not given. So this type of the data set, if you have, so you can perform unsupervised learning. Okay, because unsupervised learning, you don't know that what the data set is, what is the target of the data set, target variable, target feature, or the label. So actually we say that what the ground truth is, what actually this object is called, we don't know. What this object is called, we don't know. So what different types of the supervised learning tasks we can perform, that we have to see. So one important thing is that we can perform clustering. Okay, clustering means what? Similar type of the object, similar type of the data set, data or samples, similar types of the sample, we can cluster in same group. So we can find the these are the cars. Generally, we don't know, but these are the similar objects. Okay, so we can. How can we decide that these are similar objects? On the basis of features. Okay, so here are the features. As again, I'm saying the features may be like number of wheels, volume, and the height and width. All these things may be the features. So on the basis of the feature, machine learning algorithm can cluster, can find the groups of the similar object. Okay. So for the unsupervised learning, we have for the clustering, for the that we will focus on the clustering. So different types of the clustering algorithm we'll see in 1 day. Okay, that we have defined, we have discussed on the day wise as well. So these the clustering will be. Association rules mean that you can find some associations between the objects, that these type of the cars, if car is there, so car is basically associated to this. So association rule mining is also unsupervised learning, come under unsupervised learning. So we will see in detail. So like a bike is there, so bike is basically related, associated with helmet, and this car is associated with this. Yeah, so perfume is there. Yeah, So we can perform clustering type of the problem. We can perform in unsupervised learning, association rule mining problem. We can perform in unsupervised learning, and what different types of other things we can perform. This is basically, it will come into segmentation, customer segmentation that you can see. Okay, so segmentation again will be clustering. Okay, so like clustering is there in different type of cluster. So segmentation also you can perform in unsupervised learning. Okay, so you can do something like if anyone purchasing computer, okay, these things. So you can recommend that you also purchase this. Okay, so recommendation can also be performed, okay, using these things. So okay, so in detail we will take clustering in our day-wise agenda that we have, that we need. Clustering is very important. So we'll discuss about clustering separately in a whole day, and we will implement. So basically, when you talk about the reinforcement learning, so in reinforcement learning, there are different two things you have to understand. Agent, one that is doing the task basically. So agent also, here agent is a software. Okay, then we say that this is also algorithm environment. Okay, so you have this agent, and agent will perform like a human, or that it will perform. See that, okay, it will perform some task, and on the basis of task, whether task is performed good or not. Okay, so on the basis of that action, the task, the environment will provide feedback and reward. Okay, if the action is performed good, action is good, accordingly whatever the environment needs, that so on the basis of that, reward will be your positive reward, and it will be like given positive reward, and with that some feedbacks will be given. Okay, so on the basis of these things, this agent will try to improve herself or himself. This agent will try to improve on the basis of reward and feedback. If reward is negative, so he has to perform, the agent has to perform in a better way. So all these things we can see, we will look into. And another example is like here, you can take the example of the dog and human, how the dog learns from our environment. So the human is there, human child is there. So task is this, to take the sipper or something like that, to drink milk. Okay, so in glass, the child cannot drink. Okay, so you have given this the bottle with nipple and these things. So agent, this is basically your agent. Agent is learning on the basis of the feedback and the reward. So what will be feedback and reward here? Okay, so feedback will be something something like that. Okay, reward is if the child is taking the glass, or child is taking the milk bottle. So on the basis of uh, action of the this child, that is agent, you have to give feedback, and the what is the thing, reward. Okay, so in reward you can do some punishment, and that positive reward you can say good, well done, and all these things you can give the love and all these things. Okay, so on the basis of these two things, you can say rewards and the feedback. This agent will try. Agent is basically software and all these things. The mechanism is there. So all these things, all the programming are written, and on the basis of negative feedback, and on the basis of the reward, positive and negative rewards, whether it is a positive reward or it is punishment, The agent will try to learn things. Okay. So basically, we know that these things first try to learn, do something. So agent will try to do something. So if it is correct and it is good, then that is well and well done. If not good, so then we'll try again on the basis of the feedback. Okay. So this will be called generally trial and error. So you try something. If it is there is error that is not correct, so you are going to learn. You are going to perform uh, different way. You will find to perform different way, the best way. So that we can say that we have learned what is machine learning and different paradigms or the different types of machine. Okay, so we will go to create a model, not exactly the model that in the programming, but we'll try to understand how a model will look and what different terminologies that we need. Okay, so we are taking again the vehicle one, the different types of the vehicle we have. We have machine and we have vehicles. So we have given different, see all these things that we have covered, the different types of the machine vehicles we have given. And now you can see here, what are the samples, how we are going to represent the sample when you are talking about the machine learning data set or data set in particular. Okay. So how an object can be represented, so on the basis of their feature. So number of wheels, height, weight, and colors, and different type of things. So these will be the features that we will say that these are the input features. So you will see here. So generally, you will can represent basically an object. An object here is basically sample. Sample, we talk about the sample. This is the first sample with these features. Features, you are given feature set, different types of the features. So you can have number of wheels, height, color, all these. So you can represent an object with feature set. So with feature set, you can represent in machine learning. The object or the samples can be represented using features. So these will be the features, and the features, the values. Let's say that data set, how our data set will look. That number of wheels, 4 wheels. Height maybe 2 feet. Weight maybe something like 350. Or let's say the different types of things. Okay. Color red and something like that. These will be the values. This will be the value for the first sample. This is the value for the second sample, sample 2, sample first, sample third. We have the values for the features. So these will be the features that we say input feature, and on the basis of the input feature, we will try to understand many different things. Okay. So object can be represented, or the sample can be represented using a feature set. That is one, that is terminology, that is feature and feature set. So let's move. Yeah, so as I written here something that the values. So whatever the values you will get, they assign the features. So respective feature will have some values for the particular sample. So every sample, so if this is our feature and we are talking about these things, so how many wheels are there? So this will be value, the corresponding feature, the value will be what? Your, let's say the four wheels. This is the first. So the first feature and for the first sample, second feature for first sample, third feature for first sample, and let's say different features are there. So let's only four features are there 4 features for first sample. So height, you know height and this, and color is red. Okay. So you will go for the next sample. So every sample have the values corresponding to the sample feature, input feature set. So it will again have 4 and these things, and color you don't. Okay. So the values are assigned for the these, and these are the samples. The sample 1, sample 2, sample 3. These things are there. Similarly, all these things. So a particular object, a particular sample will be represented with values corresponding to the feature set, corresponding to the features in feature set. So, okay, it has written here. So let me clear whatever I have written. So you can find here. Okay. So you see here that what different feature values are given here. 4 and weight is 6. What would the unit of this? A height maybe feet, and the weight is there, and all these things. So these will be, so basically this is your whatever the values you have, this is your x will have these features. So if you want to find, this, so x dot, you can find number of wheels. So wheel x dot, you can write this, either you can write in programming. So for the x, number of wheels, x height, height, and x weight, and different these things you can access the values. So we have input feature, we have the values corresponding to the feature, and on the basis of these, machine will learn. So this is one feature vector, second feature vector, third, fourth, fifth. So as a vector in machine learning, you can represent the one sample value as a feature vector, as a vector. So this is basically will call when we are talking about in vector space model in the machine learning and in linear algebra basically. So linear algebra is very important to learn when we are trying to understand from the scratch the machine learning. Okay, either it's very easy, but go and take one, uh, select one model from the scikit-learn and just train on the data set, and that's it. But you will not be able to understand how machine is learning, and if you want to improve the machine learning accuracy, model accuracy, then you have to understand the basic that how machine is learning, and what types of the data set you need, and which type of the data set is better to perform machine learning. So all these things you have to. So when we are talking about vector space model, means we are trying to find the vectors. So this will be your what? This will be your feature, and you can represent as a vector. Okay. So generally we say that okay, some features are not good, that they are not uh, really helpful for decision making. Okay. This is red, color is red. Okay, color is red, then this is car. Color is red, also bike is there. Okay, so that is not a good feature, because blue is there, that is car, and blue is there, that is bike also. So on the basis of the color, you are not able to perform any type of the decision. You are not going to take a decision. You can't perform the decision. Okay, so on the basis of this color feature, you can't basically conclude anything. You can't have any decision. So that will be called as a bad feature, different types. So you can, if you have, let's say, 100 features in your data set, so you can decide that which features you want to take for the model training. Okay, So we will look into when we will talk about the feature selections and data set, data pre-processing and feature selections. So this will be very important, which feature you are going to select for the model training. So you have to know that what are the good features and what are the bad features. So if wheels are there, number of wheels, so it is obvious that if 4 wheels are there, yeah, then we can conclude that this is our the case of the cars. And weight also and height also we can somehow decide. So these will be our good features. So yes, you can see here that this is the training data set. In the training data set, you have labels. So with the label and the features. Okay. So you can take only one feature and the label. You can say that I'm going to train our machine on this feature and the label. So label will be there. Label is required. Attendance, Google form. Okay. Attendance. Someone asked about the attendance. Okay. So I will provide. I have to connect with the academy because I will ask to the. Yeah. So give me 1 minute. I'm asking, and when I will receive, I will share. So I think okay. So as soon as I will receive, or if the host is listening, so please provide the attendance sheet. So let's continue. We have time, okay? So before 10 minutes or before 15 minutes, you can do your attendance. Okay, no issue. So that on the basis of the wheels, we are trying to find out the label or the class of the object. Okay, so let's say our data is this, and on the basis of this, machine is trained. Okay, so new type of the object came. Okay, new type of the object came. So and the wheel number of wheel is given, but your class level is not given. Okay, so now your machine is going. The machine has learned that the number of the wheels are 4. Then it has find some. Yeah, again I am saying that I have contacted with a man, the host. As soon as he will provide the attendance, I will provide here. Okay. So if the host is listening, yeah. So whenever the time will be there, okay, what will be the time of the attendance? So they will provide the attendance sheet. So okay, now machine will be able to predict that this object is what. Okay. So on the basis of these things, so some concept of the probability is there, number of type of the machine, that is car, a number of wheels, that it can provide some probability. So you can check here. So probability of being car when the number of wheels is 4. So in this data set, you can find this probability is 100%. If the to find the probability of being a car when the number of wheels are 4. Okay, so and you can see the probability of being a bike when number of the wheels is 4, that is 0, because no bike is there that has 4 wheels. Okay, so on the basis you see the probability of being a car when the number of wheels is 2. So again it will be 0 because no car is in our data set that has 2 wheels. So this way bike also you can see that all bikes has 2 wheels, so its probability is 100%. So now on the basis of this, it is given and you can find out the probability. So the probability 100% or more than 50. You will see later on that how we are going to classify on the basis of the probability. So generally what we do is greater than 50% probability of any class. So we are saying that that object or that symbol is belonging to that respective class. So here you will see 2 wheels are there. So we can say that this is a bike. Okay. So on the basis of these things, you can see how these things will be classified. So if the wheels are 2, then it is bike. If wheels are 4, then it is this thing. So on the basis of wheels, on the basis of only one feature, you can say this one. Okay. But what if our data set is like this? Okay. So on the basis of this thing, you can't say this you have a car, but this car has only 2 wheels. This is a bike. Let's say these are toy bikes and these are bikes and car. This bike has 4 wheels, but it is a bike. So now you will find the probability of being a car when the wheels are 4. Okay. So out of the 4 samples of car, 3 having 4 wheels, so you can say that it's 3 by 4, so that will be our 75%. Okay, and one bike is there that has 4, one bike that has 4, so out of 4, one bike, so 1 over 4 will have that will be the probability, that is 1 over 1 by 1 by 4, that will be your 25%. Okay, so this way we can decide this thing, that what is this. You see here two wheels are there. 2 wheels, then what will be the probability on the basis of this data set? Okay, so it says it will be bike. Okay, because what? Being a bike when the wheels are 2, being a car when wheels are 2, so being a bike when wheels are 2 is 75%. And being a car when wheels are 2 is only 25%. Okay, so on the basis of this thing, it will decide that this object is a bike, but it is incorrect. Okay, because this is basically a car. Okay, so this way you can do these things, so your machine learning model is not 100% accurate. So we will look the accuracy and other things, that how a machine learning model can be evaluated and how machine learning model can be used. Okay, so okay, so you get the attendance and feedback form, so you can fill it, but still we have half an hour, so just we will complete this and we'll see the tools and the programming language that we have to do. That will take not too much time. Okay, so almost all of you are using Python, and you already have used the Jupyter Notebook and these things. But if someone has not used, someone is not using, so I will show that how you can perform. Okay. So these things are there. If you are going to take two features, wheel and number of wheels and height, so on the basis of two wheels, you can perform these things. Okay. So you can say height is high, low, and high. So on the basis of the what type of the height is high, height is low, HL. So on the basis of these things, you can do and you can perform the you can take the probability. So if height is high, so it is high and the number of wheels is 4. So the probability of being a car is 100% because 4 and height is h, so all the samples are the car. So this way you can perform, you can check all these things that being a car when wheels are 2 and height is h, so that will be 100%. Okay, so now on the basis of in the previous one that we have taken only one sample, only one feature we have taken. So this sample, categorizing the sample was incorrect. So now if you are taking two heights, two features, so you can see here that now the machine the model will able to perform correctly. So that is car. Okay. So you can see here, if the wheels are 2 and the height is h, then probability of car is 100%. So this will be a car output. So this way you can find two features, and on the basis of two features, you can see that how the objects are categorized. So this is very good feature. You can see here. So basically, you can perform this decision on the basis of number of wheels 4. So yes, 4. Then you are going to check what is the height. Height is h or not, yes, no. So on the basis of this, these are the cars and these are the cars. Okay. So these things you can see. So we'll see that this type of the learning we will see in the decision tree. Okay. So when we'll talk about the decision tree, we'll perform this. So in summary that okay, so basically here you can perform decision tree model, but we are going to learn in detail this model when we learn about the how you are going to perform regression of the classification. So in summary that we identified the features, we have seen the different types of the features we have seen when we are talking about the classifying the object related to vehicles, that is car and bike related. So in that we have seen features, what are the features, number of vehicles, height, weight, color, different types of things. How to represent vehicles by the features. Okay, so we have seen the feature set and the values, corresponding values for the feature set. Okay, so some you can remove some non-informative features that we have seen, that is bad feature, that is that was in our example, that was color. With the classification model from the data, and so this is not exactly we have built, but in theory we have seen that how you can build a machine learning model, classification model. So task, how we have performed tasks, that you can see these things. These are the tasks that after training you can perform, giving the data set and the data set with feature. So on the basis of those input feature, our model will be able to classify the object or the sample. So for this, for the theory part, we have to conclude here. And that if you go to the home, you can see that we have decided to work on other things. That this agenda was like the introduction to machine learning. So we have seen supervised and supervised and how to represent a sample, okay, and different things we have seen. So tools related things that I want to discuss, that is Python and Jupyter Notebook, Pandas, NumPy, and so all these things. So I think most of you know that we are going to use Python, and you can use different type of the IDE. Okay, you can use Jupyter Notebook, and you can use other one, and different types of the Python libraries that we will use. Okay, and one important machine learning libraries that uh, we are going to use. Okay, but we will discuss when we will build scikit-learn. Okay, but we will discuss in detail about scikit-learn when we will working on the model building. Okay, so let's try to understand these things: how to install Python, and how to import a data set, and to work on that. So let me share the screen for the okay. Me stop the sharing, and then let me share. So basically, let me share entire screen so that you will get all the things, not only one. Entire screen. So yes, you have to use Python, and I think every one of you have installed the Python, but still I have to show that how to install Python. So you can go Python and just search for the download. You can just download for the. You will go this python.org, that is our official, and you can see here that what is the latest version. Okay, so you can find here directly that the latest version is 3.13.3. So you can download the installer here. Okay, other way you can download, so go to download here, and this Python is there. And if you're using Windows, then you can go for the Windows. There are different ways, but just go to the home page to download. Okay, where download is there, and you can download here. So after downloading this, you will get an installer to download, and when you will open so it says that upgrade to this one 3 point, because um, I have 3.13.0. Okay, so directly you will not get this one. You will go and you want to upgrade. You have previous version, you can upgrade, or just you can go with the customization. Okay, so all these things, what we basically we need, and ideally that our enter will be there, and ideally development. So Python, ideally a basic, ideally you will get. Okay, and these things you can get for the check also this documentation. So I go for the next, and for these things one more important thing is there that you have to check for that. So you can check for the all users I in the first that I have checked for this one for all user you and any guest user is there. So okay, all these things that file launcher will be there. So you can check respective one. And yeah, this is very important. This part, add Python to environment variables. Okay, so it will be added to your system environment variables. Okay, so this is very important. You have to click this one and just go for the installation. So I'm not installing because already I have installed okay one version 3.13.0. So and one more recommendation that you don't install different versions of the Python. Okay, you have only one version, either a latest version or any previous version if you have. So keep that only one version of Python. And if you are installing other ones, so you just go, just upgrade only. Okay, just you can upgrade. So this is very important. So after installing, you will get that your Python will be installed, and now you can check how to whether your Python is installed or not. So you can use command prompt or the PowerShell you can use if you are using. Okay, so you can go and you can check for the Python whether your Python is installed correctly or not. So you go in command prompt and just check for the just write Python or only py and space then hyphen hyphen just minus sign 2 times and you write version. Okay. So whatever you have installed, if you have installed latest one, that is 3.13.3. So your version will be here. And as I have installed 13.01. Okay. So it's safe. Now you have when you have installed your Python. So with that thing you will get Python ideally. This is basic Python ideally. So using this, you can practice here. Okay, if it can work as a calculator, you can practice here. Okay, so 8 plus 13, you can write a function, you can write hello, different types of things you can perform here. Even everything you can do here. But if you are going to work on the larger projects, okay, someone has raised. Okay, yes, please. Uh, Minal Pathak. There's any doubt you have? You can write in chat basically. Either, okay, you can unmute, no issue. Send attached. What is this? What you need? Minal, just let me complete just only 5 minutes. Give me 5 minutes and I will complete the things. Then you will have 10 minutes for the discussion. Okay. So when you install the Python, now attendance sheet is here in chat only. In chat attendance sheet is there. Okay. So Smita has sent chat in chat. Okay. So you have find. I think if you have joined later, so you are not able to see. So let here you can find. I think this is yeah. Okay. Thank you. Thank you. Thank you, Susmita.
Welcome, sir.
Yeah. So yeah, let me complete the things. So Python is installed correctly. Now the thing is that you need a proper IDLE. You have basic IDLE when you install the Python. Now you can install Jupyter Notebook. Okay. So you can see here how Jupyter looks, Jupyter Notebook or Jupyter, you can search for that. Okay. And if you go, so Jupyter Notebook, you can download and install separately, and you can install using pip also. So just go to command prompt or the terminal, whatever you are using, just you can write pip install. And if you want only notebook, so you can write notebook or something, but you can write Jupyter. If you're writing Jupyter only, okay, so it will install all the things related to Jupyter. Okay, so it will contain many things in Jupyter. There are different things are there. Notebook is there, I kernel is there, I kernel is there, and notebook is there, and other parts are there in Jupyter. Okay, so what we will do, we will just pip install this thing Jupyter. So after this thing, you will get install Jupyter. Let's check that what different things that we have installed in Jupyter. Okay, so you can check after installing Jupyter space hyphen version. Okay, so when you install using Jupyter, pip install Jupyter, only Jupyter if you're writing, so you'll get all these things. IPython, you'll get IPy kernel, you'll get all these things. Jupyter Live, you'll get, and notebook you will get. Okay, so most of the time we will work on the notebook. Okay, Jupyter Notebook. So the Jupyter Notebook will be installed. Okay, when you are installing pip install Jupyter. So to open Jupyter Notebook, you can open using this command prompt. Just you can write Jupyter space notebook and enter. You will get that your this type of the Jupyter you will see here. Okay, so now what you can do here, basically you can create a new file and these things you can check. And if you want to create a Python kernel, basically IPy kernel, so how will it look like? You will just click here and you will get different cells. You can here perform you can write here your task. Okay, so for these things that we have discussed, we need what we need, the pandas, numpy, matplotlib, different type of the libraries. Okay, so using pip only you can use, you can install. Okay, pip install what? Pandas. You can use pip install numpy. Okay, so for that thing, for checking the exact syntax, you can check pip install. Just you can go pip install anything, that whatever you need. Okay, so you will go to this website, PY. Okay, you will get this website, and here your the command will be there. So just copy and paste in your command prompt. It will be installed. So let's say here you want to install pandas. So you will check pandas. Okay, so your pandas, this is there 2.2.3, and just you copy this thing, you copy here and just put here and run. So because I have already installed all these things, but due to if I am installing the latest version, so some conflict will be there. So I'm not installing pandas and other things. I have installed all these things. Okay, so how can you check that all these things are installed? So in your Jupyter Notebook, you can also check. Okay, just to import whatever you need. Let's say that you need numpy. Okay, so you have installed using. You can check here that what is the numpy. What is the syntax? Exact syntax. So numpy will be here, and you will find numpy, pip install numpy. You copy here and just go and write here, just paste here. Okay, and just hit enter. You will that will be numpy will be installed. Okay, so and you can check, just import numpy If import is okay, everything is fine, okay, then this means that you imported numpy, that is numpy is correctly imported, that is installed and imported. And other is what is that? NumPy pandas or the matplotlib with them. Just to check, you have installed, yes, matplotlib also installed. So just you have to go this website and you find the exact prompt. Okay, sometime prompt is different. Like if you are going to open CV, okay, so you'll get different types of the, but which one is correct one? So that you need for the Python. So to get a proper version, proper command, you just go this website and check. Okay. So yeah, other one is import matplotlib imported pandas. You can check for pandas. So you just pip install these things. Okay, pip install numpy, pip install matplotlib, pip install pandas, and you will get installed all these things. You import it and you check all these things. Okay. So I have taken here just you can check for this thing. This is very simple one. And when talking about matplotlib, so matplotlib can be used to for the graphical representation. Okay, for the plot you can make different types of the plot. Okay, linear, scatter, graph, bar graph. There are different types of the plot you can perform. Okay, so one of the important graph is there, that is scatter plot, one of the plot. Okay. So on the basis of these plot, you can find the relation between two different features. Okay, we will see in detail. And that I wanted to discuss this part, that yeah, you see here only. Okay, so to import panda, just import pandas as PD. Okay, if you have written PD here, so now onward use PD for the pandas. And if you have your data set as a CSV file, so you can use dot read CSV. Dot read CSV is a function provided by pandas library, this library. Okay, so you provide the path of your data set and you will get a rate. Okay, so you read this data set into this variable. This is df. Df is data frame, basically short form of the data frame, that is the single variable. Okay, so now onward you can use df. So to check that what are the first five entries, first five entries. So these are the samples. First sample, second sample, third, fourth, fifth. These are the samples. Okay, and these will call the features. Feature 1, feature 2, feature 3, 4, 5. So we look in detail, and you can find also that data frame dot tail also. So tail means it will give you the last five rows, last five samples. Okay. So these are the things that we need to discuss for today's. Okay. So we have set up, we have installed pandas, numpy, matplotlib, and when we will when we will create our model, so scikit-learn is there. That is very important machine learning library, that all the models, supervised and unsupervised models, are provided by this library, that is scikit-learn. Mini task that load and explode the dataset. So we have loaded the dataset, and there are different things that we can perform on the dataset. So when we will deal with yes, so when we will deal work on the pre-processing and feature selection, pre-processing and feature selection. So we'll see all these things, that how you are going to pre-process data, what are the which feature is good feature and which feature is bad and which feature you want to remove. You will also see the outliers. Some data points or outliers are not there. So how to deal outliers, how to deal with categorical data. Okay, categorical feature. These are low, high, low, high. These are clear and whether it's clear and these type of things and morning after morning. These type of the things are the categorical data. So we have to deal these categorical data because machine learning model will work on only these numeric values. Okay, not exactly, but some models are there that can work on the categorical data also. But we will try to like deal with how we are going to convert these categorical data to numeric. So different types of the task you have to perform while working in the pre-processing. Okay. So I hope for today's session, this was helpful for the students and for the tomorrow. So see here what is the agenda for the tomorrow. That will be supervised learning and regression. So we will see in detail supervised learning and we will check about the regression. Okay, so we will implement the regression model and we will see on the real data set. Okay, we'll import data set and we'll try to build a regression model. And the theory part also will check the different things inside the supervised learning and regression. So I hope that this was helpful. So now we are about to conclude the session. So over to the host. So
Yeah, thank you, sir. Thank you so much for your valuable class.
thank you. Welcome.
Yeah, so we'll meet again by tomorrow at 7 p.m.
Okay, that's fine. Yeah.
Yeah, thank you. Yes, students, I hope you all marked your attendance. If you have not marked your attendance, I'll be sharing once again on the chat. Kindly mark your attendance. So yeah, we are done for the day. We'll be winding up. Tomorrow we'll meet at 7 p.m. Thank you all for joining. Good night. Thank you, everyone.